To get electrical and electronics engineering notes, install the app from the link in the comment section below. In this video, we will see an example on phasors. Question: using phasors, find. We have to simplify this. So, solution: first we will solve problem A. Now here we have to add this or subtract this. So here we can see this is given in time domain format. We can convert this into its equivalent polar form or phasor domain form. So first of all, 3 cos 20t plus 10 degree, we will write this as it is, minus 5 cos 20t minus 30 degree. So from here we can see the omega value is equal to 20 radian per second. Now this is given in standard format, so we can directly convert time domain to phasor domain. So this will be 3 at an angle 10 degree, then minus, now this is also in standard format, so it will be 5 at an angle minus 30 degree. Now we know that addition and subtraction are better performed in rectangular form. So here this is given in polar form. So Z is equal to R at an angle phi. This is called as polar form. And Z is equal to X plus JY. This is called as rectangular form. We need the value of X and Y. So X is equal to R cos phi and Y is equal to R sin phi. That means Z is equal to R cos phi plus J R sin phi. From here we can take this R common. So Z is equal to R in bracket cos phi plus J sin phi. So this is how we can convert from polar form to rectangular form. Here the polar form is 3 at an angle 10 degree. So 3 at an angle 10 degree. This is the value of R. This is the value of phi. So this will be R in bracket cos phi plus J sin phi. So R is 3 in bracket cos phi value is 10 degree plus J sin phi value is again 10 degree. We can solve this in calculator directly. So 3 in bracket cos 10 plus I into sin 10. So this is 2.95 plus 0.52 J. So this is the answer in rectangular form. Then here it is 5 at an angle 5 at an angle minus 30 degree. 5 at an angle minus 30 degree. So this is the value of R and this is the value of phi. So R in bracket cos phi plus J sin phi. R value is 5, cos phi value is minus 30 degree plus J sin phi value is again minus 30 degree. We can solve this in calculator. 5 cos minus 30 plus I into sin minus 30. So it is 4.33 minus 2.5j minus 2.5j. So therefore this is equal to in place of this 3 at an angle 10 degree we can substitute this value. Then minus in place of this 5 at an angle minus 30 degree we can substitute this value and this will be in bracket. So bracket close. So this is equal to 2.95 minus 4.33. 2.95 minus 4.33. So it is equal to minus 1.38. Minus 1.38. And here this is 0.52. 0.52. Then minus plus 2.5. Plus 2.5. So it is 3.02 plus 3.02j. So this is the final answer we are getting in rectangular form. So this is equal to, we got this value. Now we will convert this into polar form. So z is equal to x plus jy. This is called as rectangular form. And z is equal to r at an angle phi. This is called as polar form. So here this is in rectangular form, we have to convert it into polar form. That means we need the value of r. So r is equal to under root of x square plus y square at an angle phi value is tan inverse of y by x. So we have to solve this. Let's copy this from here. So this will be equal to r at an angle phi, that means under root of x square plus y square at an angle tan inverse of y by x. So the value of x is this and the value of y is this. Also here we can see the real part is negative here. So we have to add 180 degree here plus 180 degree. So under root of x square is minus 1.38 square plus y square is 3.02 square at an angle tan inverse of y by x. The value of y is 3.02 divided by minus 1.38 plus 180 degree. When the real part is negative, that time we add 180 degree to it. So this will be under root of minus 1.38 square plus in bracket 3.02 square. So it is 3.32 at an angle tan inverse of 3.02 divided by minus 1.38 bracket close plus 180 degree. So this is 114.55 degree. Now we got our final answer in polar form for this problem, and the value of omega is this. So we can directly solve this, or we can directly convert this into this polar form or this phasor into sinusoidal form again. So this should be equal to 3.32 then cos omega t. The value of omega is, here we can see the value of omega is 20. So 20t plus 5 value is 114.55 degree. So this is the final answer for problem A. Then next problem is this problem B. So let's copy this from here. Now we will solve this problem. So solution, here we can see this is not in standard form, it is in sinusoidal form, sine form. We have to convert it into cosine form. So to convert from sine to cosine, let's go to the basics again. Here this is plus cos omega t, this is plus sine omega t, this is minus sine omega t, and this is minus cos omega t. So here we have to convert from sine to cosine. So if we go from here to here, then this direction is negative. So we have to add 90 degree. That means cos omega t minus 90 degree is equal to sine omega t. That means we can replace this sine omega t by cos omega t minus 90 degree. So let's put it here. So this will be 40 cos 50t, 40 cos 50t, and since we change from sine to cosine, so we have to add minus 90 degree. So minus 90 degree plus 30 cos 50t minus 45 degree, 50t minus 45 degree. So now this is in standard format. We can convert this into its equivalent phasor form. So directly it will be 40 at an angle minus 90 degree plus 30 at an angle minus 45 degree, 30 at an angle minus 45 degree. So now we will convert this into its equivalent rectangular form. So directly we can write here 40, we know the formula, or here we can write first step by step. Addition and subtraction are better. Addition and subtraction are better performed in rectangular form. So Z is equal to R at an angle phi. This is called as the polar form, and Z is equal to X plus JY. This is called as the rectangular form. So we have to convert from this to this rectangular form. That means we need the value of X. So X is equal to R cos phi and Y is R sin phi. So Z is equal to R cos phi plus JR sin phi. In place of this X we can substitute R cos phi. In place of Y we can substitute R sin phi. We can take this R common from here. So Z is equal to R in bracket cos phi plus J sin phi. So now we have to convert this 40 at an angle minus 90 degree. 40 at an angle minus 90 degree is equal to R in bracket cos phi plus J sin phi. So R value is 40. This is the value of R and this is the value of phi. Cos, again phi value is minus 90 degree plus J sin minus 90 degree. So this will be, you can solve this in calculator directly. 40 in bracket cos minus 90 degree plus I into sin minus 90 degree. So it is minus 40J, minus 40J. Now similarly we will do this for 30 at an angle minus 45 degree. The same formula we use here. R in bracket cos phi plus J sin phi. This is the formula used to convert from polar form to rectangular form. This is R and this is phi. So R is 30, cos phi is minus 45 degree plus J sin minus 45. So this is 30 cos minus 45 plus I into sin minus 45. So it is 21.21 minus 21.21 J. 21.21 J. So now this should be equal to, this is equal to in place of this we can substitute this value minus 40J then plus, in place of this 30 at an angle minus 45 degree we can substitute this value. So let's substitute it. Now here the real part is 21.21 and this will be minus 40 then minus 21.21. So it is minus 61.21 minus 61.21 J. So this is the answer we got in rectangular form. Now we will convert this into its equivalent polar form. So we will use this formula under root of, let's copy this from here first. Here we can write convert this into polar form. So let's copy this from here. And this is equal to under root of, we need this in this form, r at an angle phi. So r is under root of x square plus y square at an angle tan inverse of y by x. So under root of, the value of x is 21.21 square plus the value of y is minus 61.21 square at an angle tan inverse of y by x. So y is minus 61.21 divided by 21.21. So this is under root of 21.21 square plus in bracket minus 61.21 square. So 64.78 at an angle tan inverse of minus 61.21 divided by 21.21. So it is minus 70.88 degree. Now we can convert this into its equivalent sinusoidal form. So it will be 64.78 cos omega t. The value of omega is, here we can see we are solving this problem B. So the value of omega here is 50. Here we can see the value of omega is 50. So it will be 50. So 50 t minus 70.88 degree. So this is the final answer for problem B. We can write it like this. Let's copy this from here. So this is equal to, this is equal to this. This is equal to this value. Now next is problem C. So for problem C, let's copy this first. Solution. Now here again this is given in sine form. So it will be 20 cos 400 t. Now since we change from sine to cos, so we have to add minus 90 degree to it. Then plus, this is already in standard form. So 10 cos 400 t plus 60 degree minus 5. Now again this is in sine form, so in cos form it will be 5 cos 400 t minus 20 degree, and since we change from sine to cosine, we have to add minus 90 degree to it. So now we can convert this into its equivalent Phasor domain form. So it will be 20 at an angle minus 90 degree. Here we can see the value of omega is same, this 400, 400 and 400. So 20 at an angle minus 90 degree plus 10 at an angle 60 degree minus 5 at an angle. Now this will be minus 20 minus 90. So it will be minus 110 degree. Now we can convert this into rectangular form directly, or we can directly solve this in calculator. So let's solve this in calculator directly. 20 at an angle minus 90 plus 10 at an angle 60 minus 5 at an angle minus 110. So this is equal to 6.71 minus 6.64 J. Now we can convert this rectangular form to polar form. Shift 2, 3. So it is 9.44 at an angle minus 44.7 minus 44.70 degree. So now this can be written as 9.44 cos omega t. The value of omega is 400 t minus 44.70 degree. So this is the final answer for problem C. So this is how we can solve these phasors, or this is how we can add the phasors or add the sinusoids. Don't forget to like, share and subscribe to this channel, and thanks for watching.